these 3 paddocks that are in this section around this, this gate corner, these are some of our sheep paddocks, so they get really hammered. There's very little rest, but it's nearly all kikuyu, so I think that it can handle it. This paddock that we're in here and the paddock straight behind you, that's Swamp 1 paddock there, and this is Swamp 2 on the left, and this is Little Quarry. These 2 paddocks have been grazed all summer. The one on the left has been rested all summer, and I think it says a lot for the ability to graze and consistently grow feed, because in my mind there's not much difference between these 3 paddocks at this point in time. And so we've had, what I work out, Swamp 1 has had a total of 48 days grazing, Little Quarry here has had 34 days grazing over summer, and Swamp 2 there has had 0 days grazing, and there's almost no difference to my mind, except for the fact that there are some sunflowers in there. So you know, in terms of the adding livestock to a production system, you know, I'm sure there's a level of, we've been taking nutrients out of these, you know, out of these pastures because we're taking wool and meat off of them, versus this paddock that it hasn't. So there's probably a slight, you know, elevated level of nutrient in that pasture, but in terms of the pasture quality and the fodder available at this point in time, there's no difference in my opinion. So anyway, so that's the paddocks and where we are. So I did this is as deep as the soil key goes. If you have a little scratch around and find where the tine went, it's variable, but I'd say between 3 and 4 inches it went in. It's really soft in those tines, and in between there's all existing kikuyu, like is just out there. And in my experience, in about 2 weeks time, if we get a little bit of rainfall just to settle this dust down, there'll be green new growth, and it'll be a lot better than, you know, it would have been if we haven't touched it. So from the soil key point of view, they call that the remineralisation of the existing pasture, where you are digging soil out of these the tine rows and kicking it up onto the surface, so that reinvigorates the existing pasture with nutrient and with minerals. And on their numbers, they get a 15% increase just by aeration on their trial sites that are on their website. Who knows what that number is, but I can tell that everywhere we've put the soil key, the existing pasture is doing better. So yeah, the mix I've put in here is the winter mix that's back in that in the bucket back there in the shed, and we this is the second time we've put the soil key across this paddock. So if you look at the untouched bit there, we've got slightly off tine rows at a slightly different angle. So we soil keyed this with a summer mix mid-November. That was about as early as we sort of got out and got onto the place to do it, and that's pretty much the germination we got. So when John was speaking about the failed summer trials that we were doing, we were part of that as well. But pretty much everything, especially where we've got the heavy kikuyu, there was very little persistence. We got germination, but then it died off. And you know, if you listen to Christine Jones, any germination and any life that takes hold is of benefit. So we just put that down to soil conditioning and soil health benefits, rather than feed quality and production.
So have you done this before? You said once, I think. So what do you expect to come up here? Is it gonna be successful from what you did last year in autumn?
So last autumn we did the Swamp 1,
yep,
just straight behind you, we got really good activation of the existing pastures that were there.
Yeah.
Really good feed quality. Some cereals popped through, and I wouldn't say that it was great feed value off the newly germinated stuff, but in terms of the soil conditioning aspect of the machine, I think, you know, I think we fed our sheep better than they've been fed because of it for a while, because we like to leave them here on these great kikuyu pastures.
You're doing lots of experimenting at different times of year with different seed mixes, which is great. And I'm sure this will work out, but I think I imagine it's going to be a window in autumn where the kikuyu is slowing down and there's enough soil moisture for those winter things that you're sowing for winter things to germinate before it gets too cold, because the problem is it gets so cold and overcast here during winters that everything just sulks and doesn't really...
Yeah, everything slows down and goes dormant.
Yeah, and then I think same at the other end, I reckon there'll be a window where...
Yeah. So everything this last season, everything we planted after the 14th of May, I think it was, we got almost no, well, we got germination, but almost no growth. Before that, we had a decent amount of growth prior, before everything started slowing down. But we started late, and we're starting to get late again now. My preference would be to be sowing, like running this machine across in, you know, end of January through February, so that as soon as there's some moisture in the ground, the first things to pop up, apart from the kikuyu is going to go green, is some newly germinated seed. And I think that would give every different seed that's in that mix the best chance of utilising the chemistry that's in there. Yeah, rather than the kikuyu snapping it all up quick before it, you know. Yeah.
Derek, do you think the summer crop you planted here, do you think, you said it sprouted and then the seedlings died off, do you think that was because lack of moisture on this particular season, or competition, or any ideas?
Yeah, well, I think it was, I think germination was good because of the moisture in the ground, because we had really good rains through November. So, you know, that's why we couldn't get on earlier. I'd love to be seeding in August if I could get the tractor there, so that, you know, that last burst of spring really gets some of that germination going, especially because the soil key, it really busts open that tine row and there's nothing there living. You know, where you put the seed, in theory, there's no roots there, there's no live plants. It is, you know, a few inches to the right or left, but right where it is, it's got best seed to soil contact, and I think one of the, you know, as good a seed bed as you can have. And then this year, this last year gone, really it just got really hot. It was wet underfoot, and we were, you know, sloshing through the paddocks in our boots, but it was, you know, it was baking on top, and so you could sort of feel the pasture wilting on top and drowning from underneath. And so yeah, it was just an anomaly of a season in terms of summer fodder for us. So I think it would be a while before that happened exactly the same again. I don't think that's a continuing trend, but, you know, it is what it is. So just run with it. Yeah, it took off in spring. So we had really good spring growth from our autumn planting, but again, where the kikuyu was heavy, it was very minimised. You know, yeah, because the kikuyu got going faster than everything else got going. Yeah.
That would have been, if it had been a normal year and you'd done it in November, wouldn't that be the same way?
Maybe, yeah. That's the thing. Who knows? It's one of those things. A new machine in a new area that there isn't any data on it. Yeah. It's hard to know exactly what the best way to get going is. Well, so the soil key was designed to, the end result was that it's patented for building soil carbon over repeated usage, as long as you're not also doing other management practices that are going to minimise that carbon buildup. So you know, it's designed as adding seed to a system without the need for chemicals, either sprays or fertilisers, that sort of thing. So that's how it was designed. Where they designed it, they did have some kikuyu, and they have found it really good to use on their kikuyu repetitively. But it's Gippsland, they've got a bit more rainfall, it's a little bit more consistent, bit longer growing season. We've sort of got a growing season cut in half. You know, we get 2 growing seasons and 2, like a cold dormant season and then a hot dormant season. So I think that's where, you know, tickling it around the edges and just getting those little bits right is going to make the biggest difference.
Regards to any fertiliser, like was said before about that liquid fertiliser that was shown beforehand, do you add anything to the seed type of thing? And whether there could be any comment about whether that would possibly help?
I think it would help. We haven't been, because we invested a lot of money in the machine and we want to see what the machine can do of its own accord in terms of its mechanical effect on the soil, rather than continuing to, you know, add a little input here and a little input there. But at the same time, especially on these kikuyu soils, it may be better to be adding a nutrition, you know, with the seed, whether it's a pelletized worm something, or a compost, or something or other with the seed, so it's dropping right there, giving that new seed the best chance to get away without the kikuyu really, you know, taking over. But I think really the mechanical action of cutting this kikuyu up into smaller and smaller pieces and reducing that root thatch is what's going to, you know, enable other species to start to dominate in some areas other than, yeah. Joel, do you want to comment on that?
Sure, you wouldn't necessarily have to add something, but it could be an opportunity. I agree, and I think I would lean towards a seed treatment from a biologist, because you're sowing in a diverse mixture. I would lean to something like a compost extract, vermicompost extract, where you're putting that diverse biology around all of those different seeds to potentially provide that microbial interaction with all of those diverse roots and diverse root exudates to then, you know, exploit some of those synergies that we talked about in the lecture. So if I were to, I would start with a simple microbial compost extract on the seed treatment. Now beyond that, whether or not the soil key has got the capacity to be dribbling liquids in as well or not, maybe not, but I think even a standard seed treatment on this annual mix would be a wise idea.
I forgot that I did actually order a vermicast extract on the seed this last year as well, which was an added bonus. I don't feel like I did anything to that though, but so I don't think about it. So
does it make it too rough to drive big vehicles along?
yes.
Yeah.
So Joel, have you come across systems similar to this, trying to sow more diverse pastures into existing pastures without spraying them out? Do you have any thoughts on this system, or pointers, I guess, or tips you might?
Yeah, people are talking about this is a similar conversation happening in other parts of the world, and this idea of trying to kind of stitch annuals and things into pastures is very highly variable, really mixed results. Some people seem to get it to work, others really not. And I think that obviously in a pasture situation where you've got such a competitive grass in there, I think some level of this kind of disturbance is required. So there are things happening like a bit of strip till and then trying to drill into that. So that's kind of happening, but so I guess it's kind of similar, but a little different. But yeah, of course, I agree. There is a challenge when you're dealing with a pasture and it's in that competitive nature. You know, some people that are then drilling in, trying to replace, say, a standard kind of perennial ryegrass or ryegrass clover, and try and move into some of those multi-species swards. Again, you also get quite a mixture of results, and many do feel that they're getting better results when they do spray it out, just because it's less of that competition and everything has that chance to germinate and establish, and you get a more even multi-species mix. Of course, it's hard for some plants to compete if you've already got such an aggressive grass growing, and sure, there'd be some kind of suppressive effects there, some of those root exudates from the grasses that may be alleliopathic, maybe suppressive germination on some of those plants. Some would be favourable, some potentially not. So I think in that whole context, some really feel that they do think that it's either got to be the plough or the glyphosate to kind of clean the slate, and then you will get better establishment of everything. But I think that as a middle ground compromise, I think that how I understand the soil key system is being used is that it is also a repeated process. It's not a once-off. So you're doing it a few times in successive over the years. So I think for me that opens up maybe a compromise of saying, well, look, even if we don't get perfect germination of everything this time around, you're going to be repeating that next time around, and maybe it'll be, again, the environmental conditions could be a little different then versus, whatever, spring versus autumn in those 2 windows type thing. And then over the years that some of the different species will germinate and others in different times, different years, etc. So maybe it would all even out in the wash in that regard.
Joel, if you did get to a point where you made a decision, you want to start fresh basically, do you have any views on tillage versus spraying it out?
That old question. Of course, they're both disturbed. What's that?
Do both.
Yeah. Well, okay. Some people do both. That's common somewhat in the UK. Spray it out first and then plow. I think that's absolutely madness. Crazy. Unfortunately, we have to put on our practical, pragmatic, compromising hat in here in these types of question. It's a difficult one. Neither is ideal. I don't think neither of us necessarily want to be doing either of them. And I think you've got to choose your disturbance, be that mechanical or chemical disturbance, appropriate for your context. In a very dry country like Australia, I'd say there could be an argument for the use of glyphosate. I'm not a keen glyphosate, necessarily super keen on it, but I acknowledge that lack of disturbance that it provides in a very dry environment is important to try and keep your soil moisture. In dry environments, I think that is important. In the more temperate climates, where you've got also different younger soils, more moisture, sure, you could get away more with that physical disturbance, and it's also going to be less damaging. So yeah, it's a really tricky one. Of course, there's no easy answer to this. I think that if you're going to use glyphosate, there's this trick about acidifying it. Drop the pH right down. Drop it down to a pH of 3 and add a carbon source like we talked about today. Fulvic acid is a good one, but I know people even use molasses. And by acidifying that glyphosate, you can really improve its efficiency. And so you can use less of it, dial down the rate by about 1/3, and you'll still get a very effective kill, at least 1/3 of the rate. And that's okay, at least you're using less of it, so that's a kind of a middle ground compromise. Okay, we're still cultivating and disturbing the soil, but we're doing it in 70% of the area. Okay, also a middle ground kind of compromise in that regard.
Can you use do people play around with any other herbicide other than glyphosate? There are. Does anyone have experience with just the contact which kills what's on top, doesn't kill the perennials, but does that give that window of allowing them to come up, or it's gone? I don't know.
Yeah, it's a great question, and I know some people do, which again I know is bad practice, but I know some people apply low rates of herbicides or glyphosate or otherwise just to kind of suppress things, not to suppress a clover or whatever, but it'll always come back, that kind of thing. There's some interesting work looking at essential oils, and believe it or not, they do have all 3 fungicidal, insecticidal and herbicidal properties. And there's actually a lot of studies on this. However, of course, at the end of the study, typically the essential oils, they're not very highly effective at getting a really good kill. And so usually the outcome of the study, the conclusion will say, it gave some suppression, certainly didn't kill, was more expensive than the herbicide, therefore not viable.
Yeah.
But I think actually the question you raise is a very good example in this kind of setting too, where actually therefore some of those ineffective essential oils to kill things might be perfect tools for just suppression. And I think that could also be applying in a cropping situation as well, where you've got that legume and cereal crop where you could kind of spray that off to kind of suppress the legume, give it a knockback, it'll flush out some of that nitrogen out of those roots, help the cereal along, for example, and then the legume kind of recover from there. So I think there could be examples where maybe a softer and maybe a more acceptable input like essential oils could play that suppressive role, even though they're not going to kill.
For some people whose conscience doesn't even want to use glyphosate, you're right, that these things that research that gets dumped could actually be useful to to people that are wanting to, they're happy to spend more and not have to use glyphosate or something like that?
Yes, yes, of course. Yeah, I agree. Yeah, that, you know, the way that those studies are, they're looking for herbicide alternatives. And if we're just talking about suppression, well, that's a different goal. And the design of the farming system where you're looking for that suppression is very different to how they're thinking in some of those study designs, design kind of thing. So
You
yeah.
could roll around in it afterwards and get your essential oils.
Well, you could too, indeed. Yeah, have a cruisy afternoon, feeling relaxed with all that lavender. Yeah, there's quite a bit of work in that, and some of the quite interesting ones are cinnamon and clove oil. Peppermint oil is another one that seems to be quite good. There's a mixture of them for different purposes, but those are some of the ones.
That's why they were looking at essential oils for lice treatments on sheep. So it's interesting
Also.
that there's a lot of look at those sorts of things, because I didn't realise they had those three actives, I suppose you said, fungicidal and
herbicidal, yeah, and insecticidal,
insecticidal,
yeah, absolutely.
Does that mean we could grow hemp? Just say it's a cover crop, sheep, and then use the oil?
Yeah.
Sorry. Grow hemp for oil?
Yeah, allegedly.
Like CBD oil?
Yeah.
Yeah, I wonder if it has some of those other properties, but probably too high a value sent into the medical direction.
Take that, you don't worry about that.
Yeah, that's true too. Yeah, so yeah, back to your question, there isn't one that's better or worse or right or wrong. I think you've got to choose in your context and what you feel kind of comfortable with. And mechanical cultivation, sure, it definitely is pulling apart those aggregates. We've talked about the aggregates today. This is definitely ripping those aggregates apart. You're unlocking some potential carbon in there that can be lost. It's not ideal from a carbon loss point of view. But then again, I could share with you a fascinating study done on the effect of livestock trampling versus no trampling. And, that little bit of trampling, which is a bit of a surface cultivation, a surface integration, they showed that it was actually very beneficial for building soil organic matter. That better incorporation of the stubble, of the residue, grass residues, the litter, actually it basically enhanced carbon cycling overall. So what they showed in that one was really interesting, that it actually increased CO2 loss. The trampling increased the loss compared to no trampling, but it also increased the gain. And so that gain was much bigger than what was lost. So it demonstrated there was more carbon cycling, and that can be a challenge. If you were a study design and you were just measuring CO2 emissions, you would say, oh, trampling is worse, we lost more CO2, but we also gained more in soil organic matter formation. So there is an argument that maybe some mild disturbance, which does happen in nature and animals hoof around, then there is an argument for that. I could also translate that to the chemical. Microbes are actually very used to being exposed to chemicals, to biochemicals. That's what rootexidates are. Rootexidates are not just sugars and carbohydrates and amino acids and acids. The plant also releases many hundreds, if not thousands, of different, very specific biochemicals. And some of those chemicals also have and are meant to have suppressive effects on the biology. That's the plant's way. I talk about the plant recruiting the organisms that it wants. That's how it does that. It suppresses some and feeds the others. And so you could also argue that microbes for many millions of years are also very used to being exposed to chemicals, biochemicals through the rootexidates. And so whether that, again, of course, we all agree we're trying to transition away from chemical-dependent production systems. I fully support that, but of course, I think there's also a bit of nuance in this discussion that could argue that microbes are very well adapted to dealing with chemicals and then ultimately breaking them down. And these temporary shifts that happen in the biome, and over the long term, they may not necessarily have long-term impacting effects. But of course, that's a tricky discussion and hot debate, of course. Yeah.
we were able to embark on an ERF project with no upfront costs. Any costs incurred in terms of baselining and subsequent measuring of carbon are able to be offset in future carbon credits if and when we produce them. So we sort of went, well, no money up front. I can't really see a negative to that. So this was one of the sites that was one of the first 3 soil cores we did. We got the core jammed in here. We had to lift it out with the 3-point linkage on the tractor. We had all sorts of trouble. And if you have a chance to either step into the pit or have a look at the edges of it, you'll see how hard these ironstone sands have baked. It's not always that solid, but you know, there's a lot better people to tell me why and how. But if you have a look, if you're interested, on your piece of paper, there's 2 levels of soil organic carbon, bulk density, moisture and gravel on under soil pit 1, and that was when we did the measuring in 2019. So the top one, L1, is from 0 to 30 centimetres. So under the carbon measuring methodologies, they do the top 30 centimetres of a core, and then they do the bottom 70 centimetres. So all cores went down to a metre. And so we've just had our property re-measured this last November gone, and we've been informed that we've had a measured increase, or an indicative increase overall, and we're going forward to have a look at getting carbon credits issued. My understanding is the government holds back a certain percentage for, you know, anomalies, so that they're not just giving out money up front and then feeling sorry that they should have held some back in later stages, because all of the sites, so on 150 arable hectares that we're running here, they do 18 cores down to a metre, and they're randomised every time they do them. So of course, given that we've only had 2 randomised samples done, there's only been 36 actual holes put in the ground. So even though there's been a measured indicative increase, it's, you know, the numbers are too lean to actually say that we've actually built soil carbon, but apparently, you know, as far as AgriProve are concerned, there's enough for us to go ahead with all that paperwork, and they're doing it all. So yeah, so, you know, we may see carbon credits, we may not, but that's where our system's up to with our carbon farming enterprise. So they bag them up in the 2 samples that I said, top 30 and bottom 70. They all get trucked off to somewhere with a fancy lab, and they do all their tests. And based on you know, all their methodologies that they've got all sorted out, then they come back with, you know, the bulk densities and all that sort of thing. So
The cores actually get put out in some land reclamation areas.
Thanks, Dad, for that insight.
You're effectively mining your land.
Effectively, yeah. Without a permit.
It's hard to imagine you could get anything that would increase soil carbon more than thick kikuyu.
Well, yeah, and I mean, kikuyu thatch is very known to be a very good source of organic carbon in where the root zone is. The question is whether it can build it at depth, or whether you can get soil building effects.
So that's the key.
I think that's it.
Did you get any increase in your bottom 70 centimetres or only your top 30 centimetres?
I haven't got those results. Yeah.
Okay. So, you know, having a look through a bit of a soil profile as just a general kind of few comments to start with, and then maybe I'll talk a bit about some other thinking on the soil carbon thing. But of course, you know, you can see very clearly where our kind of more organic horizon is, the darker, where we have nice looking browner looking soil. And of course that's telling us that we have a better accumulation of organic debris, organic matter in those browner layers. And that comes back to our lecture this morning, where we talked about that process of soil formation, that growth and death. It is the depositing of the the dead plants, the dead organisms, all of the life forms that grow, and over time their dead bodies kind of go through that process, digestion, and enter, become kind of parts of soil organic matter. Let's park that because we'll come back to that discussion. But the color there straight away is telling us that, okay, in this horizon, and no surprises, it's really where most of the root activity is. This is where most of the roots are, and there's no surprises that this correlates with where we have better soil color. Now, therefore that tells you something very easy. If you're trying to increase the soil carbon content, you need to grow more roots. There's a reason that where the root activity is, where this is browner, and where we move down into these sandstone layers, these sandier, rocky layers here, that of course the color changes, and we also see less roots there. Now, okay, that said, are we getting some root penetration? Yes, we are. I can see some roots down here where it's not obviously, it's not obviously this sandy soil down here is not obviously not great substrate for plants to necessarily thrive in, but it's obviously not so hostile that the roots are just not even going in there. There is some, I can see some root activity all the way down here, kind of right at the transition of the pale into the orange. There are signs of some roots here. So, okay, so I'm sure it's not most favorable, but it's not impossible for them to kind of grow through there, like some soils can be, obviously very high in aluminium, for example. It just literally burns the root tips almost, so the roots can barely even penetrate it. So, so in some regards, I would say that's somewhat encouraging about this profile that we see here. But obviously you can see that because this is very pale here, and then we move down into the harder rock at the bottom, this harder sandstone at the bottom, it's very difficult for roots to get down there. And part of that problem may well be our choice of plants up here on the top. That, and I alluded to this a little bit in the discussion, that we have through breeding been prioritizing yield. That's been a major breeding goal, increasing above ground biomass, and this would be true of crops or pastures, grass species. We've been breeding for yield. And we did that very successfully, with the Green Revolution, where we really using breeding, and we very successfully managed to breed varieties that are high yielding, which simply just means that when they photosynthesize, they allocate more of their carbon to above ground, and therefore driving yield, more carbon above ground, and therefore it's a trade-off that came at a cost to root biomass. And so that is one of the mechanisms by which we've been increasing yield, is because we've been taking away from the roots. And we see this in many examples. Some of you might have come across the heritage wheats, for example, some of those old traditional varieties of wheats, the einkorns, the emmers, the spelt type things. Some of those older varieties, they all have really big root systems, and they're generally lower yielding. Which is why some people don't like to grow them, but okay, they're a bit more of a boutique, health food type kind of market opportunity there, but they are lower yielding and they produce much bigger roots. And that's really what we did, is we bred the roots out of the plants in order to drive yield. And for my mind, that's one of the key reasons when we talk about industrial agriculture, the intensification of agriculture since World War II, etc., and particularly from the breeding around the Green Revolution time. I think really it's this shift away from roots that we have been seeing as a key factor as to why soil organic matter has been declining, why some soils have been degrading. And I know that's a generalization. It's not that all soils have been losing organic matter or degrading, but generally most would accept that with the intensification of agriculture that carbon has declined. And it's because I think that roots have been declining. And actually roots are, as I touched on in the lecture, they are what builds soil organic matter. It's root decay, it's the root material, the root litter, the root biomass that breaks down and helps to form soil organic matter. And there's no necessarily secret about that. It's just that's because that's where they're located, in the soil. All of this stuff up on top. Well, of course, it's much harder to form soil organic matter with litter sitting on the surface. Now, at the bottom of that litter layer, if we have a mulchy mat kind of thing, sure, at the bottom of that mulchy mat where you're getting soil contact, sure, you're getting better kind of integration there and breakdown, but that mulchi-litter mat on the top of it, it's not even in the soil. It's exposed to the sun, to the heat. It's going to be oxidized. You're losing it more so as CO2. You're not building it as soil carbon. And that's that argument to the discussion I just had earlier, that study that showed with a little bit of livestock trampling, what that helped to do was create integration, mix it in a little bit, and therefore gain more from the shoot material. And so this is the important point, is that there's many studies have looked at the contribution of roots versus shoots, and it's very, very clear that roots play the driving role. They are the starring role. What happens on top with the shoots is not the key to building soil organic matter. And there's one study from 2017, which was a review that kind of reviewed all the other studies, and they came up with this kind of figure of, amongst all the, averaging it out amongst all the variability, that they came up with this figure of around about 5 times. That roots are about 5 times more effective than shoots at building soil organic matter. So if you want to build soil organic matter, you have to grow more roots, and I think the varieties that we currently use for both cropping and pastures are not necessarily the best for that. I think there is opportunities to go back and look at some of the older varieties, particularly some of the older grasses too, things like cocksfoot or timothy, or just generally deeper rooting plants. I mean, maybe not relevant for here, but lucerne, nice deep roots, plantain, chicory, some of the nice tap roots too. The deeper rooting plants are going to be the key to building carbon, but in relation to this context, sure, also deeper rooting plants that will help to start this process of chipping away, penetrating into these less ideal layers, and just slowly over time getting some roots down into there, and over time growing and dying, and converting some of this pale mid band here that you can see, converting some of that into more like the topsoil, growing more topsoil by making the soil grow down, more roots, more turning over, building that soil formation that we talked about into this kind of paler layer that you can see here. Now, would we ever get all the way down to this much more harder, rockier, orange stuff down the bottom? I don't know, maybe not. We have to also be practical, realists, that different soils in different contexts, different points in the landscape, there's only so deep. You can't just build deep soil infinitely. You know, you're going to be limited by some level of the geology or the landscape or the environment, whatever it might be, but nonetheless, I would argue that there is an opportunity here to increase the soil layer, the organic horizon here, by encouraging some roots down into here. And again, maybe other tools to support that, like a bit of mechanical intervention, cracking it open, creating cracks and crevices for roots to get down there, could be beneficial. Maybe some calcium, liquid calcium being dribbled down into there to neutralize some of that acidity down there. That might also help those roots get down there a bit more easier to address some of those low pH issues, etc. So, you know, maybe some of those kinds of tools could also be advantageous, but the key here is that we want to grow roots. Now, the other factor that has also led to suppression of roots, unfortunately, is nitrogen. Fertilizer, as you all know, nitrogen fertilizer, it's good at driving yield. And how it drives yield is by encouraging above ground biomass. It's the same. So this is the other factor. The other factor is maybe not so relevant here, but certainly is in cropping situation, is that the shift away from perennials to annual production systems. That was also not very helpful, because it's perennials that grow more roots and come back every year, so they allocate more carbon below ground, as I mentioned. So the shift away from perennials was a factor. The breeding of varieties being yield focused, above ground focused, was a factor, and the third factor is nitrogen. So we have also some very good studies that show this, that as you increase nitrogen, you increase your biomass. It's good at driving yield, as you all know, and often that comes at a cost to the roots. Now, there was a very good study just published a few years ago on maize, and it really captured, I think, the essence of this discussion really nicely. You all know about the nitrogen yield curve. As you increase nitrogen application rates, you'll get nice increases in yield, but you will reach the plateau. And the more you increase that nitrogen, the yield just stays the same. You've hit that plateau. And that's kind of the nitrogen rate, the goal we're trying to hit, is right ahead of that plateau, so that we optimize our economics and the amount of nitrogen that we need, because any more is just wasted. We're not getting increased yield. Now, that curve that you're all aware of does not apply to root production. I showed this really nicely on maize, especially. but it's also some other studies support this, that you, with a little bit of nitrogen, yes, you can increase root biomass. If it's, it's still an essential nutrient. The plants need nutrients to grow, so providing that nutrient helps them grow. So your initial applications of nitrogen absolutely increase the root biomass production as well. However, it is as we get to that peak, as we keep increasing nitrogen, the root production does not plateau. You actually suppress, it comes back down. You are suppressing root biomass production the more and more that you over apply nitrogen. So any nitrogen in excess is not plateauing root production, it is suppressing. You are reducing root production. And when roots are 5 times more important than shoots in building soil organic matter, this is also then a big factor as to why we have also seen problems with root loss, I think, over the last few decades, and therefore some of these declines in soil organic matter. I'll say one last thing about root exudates, and then maybe open up the discussion from here. But the other then emerging interesting piece of this discussion is all, of course, about the root exudates. Everyone's very excited about the role of root exudates in them to driving soil biology, feeding microbes, driving nutrient cycling, accessing all the fertility here that we kind of talked about earlier, but also potentially to build soil organic matter. And we have a real change in paradigm underway at the moment, and again, consequently, there's very mixed evidence on both sides. We can kind of really sit around and debate this, but just to give you a nutshell of what the discussion hinges around, is that previously we really felt that root exudates did not build soil organic matter, that they were too labile, they were too available, they were too small, they were too simple sugars, highly digestible, highly available, that they would rapidly come into the soil and rapidly come out. They would be released, microbes would gobble them up quickly, respire them off as CO2, that it was one of these fractions of carbon that is highly available and more so cycling in, that it was never a form that would be stabilized into the soil, wasn't complex enough, wasn't recalcitrant, wouldn't be stabilized into the soil. And so that was the kind of the prevailing paradigm that therefore said that plant litter, so all of that shoot litter and that root litter, the actual structural biomass of the plant, that is what breaks down slowly, and through that process of digestion forms what we would used to call humus, soil organic matter, that it was basically all of that plant material, not those, so this is the structural material of plant, not the metabolic carbon, which is what the root exudates are, the small soluble stuff, but the structural parts, the lignin, the cellulose, the litter, that all of this has to go through a decay process, and then that starts off being big and complex like lignin, and gets digested and broken down to smaller bits, and the microbes support this process, and it was a bit of a black box. We didn't necessarily totally know, but ultimately it kind of goes through some kind of a humification, humus forming process. And so we really felt that therefore root exudates were not important. What was important was growing more litter, more biomass, and that's been the argument why we've been also then, the argument says, well, nitrogen is good to build soil organic matter because nitrogen drives more biomass, and then that plant biomass will break down and build soil organic matter. We now know that soil organic matter is actually only about 50% made up of plant remains, plant material. The other 50% of soil organic matter is made up of dead microbes. This is called microbial necromass, the microbial dead bodies. And so this has been a big shift, because we previously thought it was mostly plants, plant decayed material was soil organic matter, but now we know it's a mixture, a combination of decaying plants and decaying microbes, dead microbial bodies. And this is very important, because then it opens up this question of, well, if microbes and their dead bodies make up a 50-odd% contribution, it just opens up this obvious question that says, well, how would we optimize that? How do we optimize the microbial contribution as compared to the plant contribution? And therefore that opens up this discussion about root exudates. If we want to grow microbial biomass, if we want to grow lots of microbes who are then ultimately going to die and form this necromass to form soil organic matter, it opens up this discussion of, well, what's the best food source for them?
Sewage.
Sewage? They can grow in sewage, can't they? Yeah. And so this is then, it opens up a question about digestibility, and that all of you livestock people will understand this very easily. From a livestock point of view, the principle is exactly the same from a microbial point of view, is that this roughage here, this lignin, this difficult to degrade stuff has low digestibility. And it's okay, it's still important for the animal, it needs the roughage, and you want that balanced, of course, with some nice greener material for nice protein and etc., etc., for all that more digestible energy. Now, it's the same with microbes. If they are presented with, and remember, I'm talking about a microbe here, a single cell bacteria or a little fungi, it hasn't got teeth or to grind up. If a bacteria is presented with this lignin, structurally complex, big, difficult molecule, versus a root exudate, which is sugar, simple, highly digestible, highly available, easily assimilated, the microbe prefers root exudates than the litter. And you will grow more microbial biomass per unit of carbon if you feed them root exudates, simpler materials, than you will lignin and difficult stuff. For the very obvious reason that a microbe doesn't have teeth and can't chew this up. It cannot just absorb this into its body and grow bodies. It has to digest first. And of course, microbial digestion happens outside of the cell. It doesn't happen internally like for us. It happens outside. So microbes start the process of releasing digestive enzymes to break this down. And those digestive enzymes are just like scissors, and they'll come along and they'll start cutting this, breaking it down to a bit smaller, a bit smaller, a bit smaller, a bit smaller, a bit smaller. So then we have this material here, it could be called like a continuum of decay. Some is still very complex, some is half broken, some is 3/4 broken, some is all the way down to the very smallest bits. Once it gets small enough, the plant material is a continuum of decay. And only once that lignin and complex stuff gets to the very end point of being small enough, small carbon chains, small little aminos, little things released, then the microbe can absorb it and eat it. And so this whole process of digestion is very inefficient in the sense that it's taking time for the microbe to just digest before it even starts to eat. Now, our other microbe, who gets a root exudate from day one, here's day one, let's start digestion. Day one, we get root exudate. That microbe is growing and reproducing immediately. It is immediately reproducing, growing biomass. Whereas our other friend is still waiting, digesting. Meanwhile, the hare, the rabbit has run away, the tortoise is still waiting. Okay, and that's the argument. So per unit of carbon, we can grow more microbial biomass on root exudates than we can with a lignin, because of this need for digestion for a small microorganism. And so that then opens up this question of this point to say, well, in terms of optimizing the microbial contribution, indeed root exudates are a far better way. And that, of course, is what Christina's talked about through this discussion about the liquid carbon pathway. It's that essence. So this is why we have gaining traction on root exudates, because we can grow more biomass and then ultimately form more of this necromass much more effectively. Now, it's not to say that therefore it's just one or the other. I think we still you want both. And it's not to detract from what litter and stubble and residues do. They provide very many other important functions. They are protecting the soil. They are keeping soil moisture. It is habitat for insects. It is protecting the soil from wind erosion, etc., etc. It's food source for earthworms. Okay, so all of that surface litter, don't get me wrong, it's still critically important. And it does contribute to soil organic matter, but just slowly and less efficiently than what the root exudates can do. And that is the essence of the argument as to why then the living roots soil health principle has gained so much traction in recent times, is because it's only living roots that are releasing those root exudates and therefore feeding and keeping the biology more active.
Joel, what about the use of cellulose digesting fungi for litter, and then its impact of speeding that up?
Sure, yeah, absolutely. So you can make better use of this litter by applying certain organisms who are specialized at unlocking that, for sure. So you can get a bit more out of it than if you don't do that. Again, they still have to go through that process of digestion, but still you're putting specialized organisms who are very good at that process to at least get a little more out of this than it just sitting on the surface for a very long time, where it's potentially then being exposed to loss of CO2. But again, providing other functions for sure, but not necessarily directly building soil organic matter. So, yeah, please, no, go.
What you're saying about maize, so if people are going over top nitrogen and keep growing a lot, the root system then, isn't that just given a bigger loss in wind damage?
Yeah, so also excess nitrogen also suppresses the production of lignin and makes the plant more taller, but also weaker and more prone to lodging. Yeah.
So
yes.
I suppose it took them a while to work that out when they realised they were losing.
For sure, it can be also a negative of over-refined nitrogen.
The other question is, this soil under here, is it like if you were to fill that up with water, how long would it take? When it rains here, does everything get wet as it's going down?
So all our sands are. Our sands here are generally non-wetting sands. So in the first instance, it runs along the top. Yeah, I mean, I would expect if you fill this up with water, it'll still be there tomorrow. You know, it's not going to go anywhere. It's fairly well.
My place is much the same, but I built a house out of it. But I was just wondering whether you would have just a pool of water underneath and stuff with roots would get down to there and then say, my feet are wet and I can't survive. But maybe it just that doesn't hold that.
I suppose it depends how deep your water can infiltrate and at what point it stops. I don't know that there's not a point in this soil specifically that I know of that the water infiltrates and then would stop and run, whereas we had a soil pit done with a university competition that we had just across the creek there, that we dug the pit, and in the week prior to the competition we had a fair bit of rainfall, and it was going down about a foot, and then it ran straight out of our pit and filled up the pit. So there was a definite water course under that surface. So and I wouldn't expect to see that here. I would expect it to get wet and get a bit more friable, but not in terms of running under the surface.
I would say we are potentially partially seeing signs of that. The reason being is that you have the organic horizon, then we have the whiter horizon, and then we have the red horizon. And we do see this in a lot of soils. If you have very impenetrable layers, when that water comes down and it hits those layers, then it will move horizontally, and it's that then perpetual sideways movement of water under the surface that then over time actually is leaching nutrients leaching them horizontally, causing the bleaching. So it's the loss of nutrients that also then can cause these soils to go white. So particularly you see this on soils with very heavy clay subsoils, which then the water is very slow to penetrate through that. You see this, and you can see these bands of white strips right above that clay layer, because it's literally stripped all the nutrients out over time horizontally. And there could be an element of that happening potentially a bit here as well.
Are you saying that more coloured layer is the more impervious to water, and the lighter is the more...
Correct. Yeah. Yes. Yeah. I mean, I'm not an expert in these soils, but so if anybody else knows otherwise, feel free.
Something you mentioned before, which I'm trying to do at our place, is like that hard yellow getting through there. The grasses aren't going through there. So is that where the grassy woodlands, paddock trees in here? So I'm trying to look for any remnant trees around here, and I don't know what was here. I don't see anything that was here before Whitefella. So a tree might be able to get through that. After 10 years, you could harvest that tree and have other trees that can then go down. So you're still getting paddock tree effect, 10 years to have the shade and everything, but that might be able to get through that.
Good point. Yeah, I agree. I think a tree root is going to have a bit better chance than a pasture plant at potentially penetrating that, and it might be therefore again that argument for the kind of the wooded pastures that then you would have at least these points of penetration into that, which then over time can become drainage points for other water in the landscape to get out through there, and help over time to kind of open up some of these very difficult subsoil layers, and again bring nutrients and things up from that surface, those deeper horizons, and bring them up and circulate them, recycle them in the surface horizons. So yeah, that's a good point. I think maybe it could be an argument for some of those bigger, stronger, woodier plants that may be able to then do that. Yeah.
Lucerne, how does that grow here? Seed guys?
We put some in last autumn.
Yeah.
It's not here.
Okay. I put some in my garden in a mix to attract insects, and within a year the lucerne taproot has gone down like that. I was thinking,
Lucerne's, I agree, it's a fantastic deep root, but it doesn't like acidic conditions.
Right.
It likes calcium, it likes quite more alkaline soils, so it might struggle a bit here.
On the other hand, Agasaceti doesn't mind acid soils.
So this whole paddock, as well as the one, well, all of these three that we were talking about, so they received this summer mix that's on the sheet. It's the Down Undercover Super Summer Mix South. So this is a little patch of, we realigned fences. So this used to be a dairy paddock, which was on, heading to the south, and there's some old fence lines that you can find if you're really looking. But this was a little patch that was a really sandy bit that the kikuyu hadn't really gotten all the way back into, and lo and behold, this is where we got that biodiversity of germination, like the rest of the paddock germinated, but we also got the persistence. But out of about the 22 or so hectares of this stuff that we planted, this is the only patch. So
That's promising.
it is.
That is for people that don't have the kikuyu problem.
Yeah, I think without kikuyu, I'd be able to grow some peat. But I just on the microbial diversity, I back in the shed had a little microbiometer chemistry set in there that I bought to be able to do field tests on getting a fungal to bacterial ratio, so that they are written down on this as well. This is about the highest fungal to bacterial ratio I've found on our farm, and it's 1 to 1. So for a while I was only doing tests that were 100% bacterial, and I was starting to wonder whether my little chemistry set was working at all, but it turns out it is, and I've just got bad soils in terms of fungal persistence. So one of the big differences between this pit and the other one, as I was digging it, is this is a soft sand base. It'll just crumble away, whereas that bit over there has set. So and we've got root zone going down, and Joel can discuss that.
Is this pretty much bare ground, these sections?
It was sandy, yeah. So apart from annual weeds and things, wireweed, stuff like that,
So I would say that it's potentially encouraging if you're saying that the sand here is a bit more friable, more potential, of course, therefore for roots to get down, and then convert that sand into deposit their bodies and build the organic layer. And I think, I don't know if people will want to come around, but to see it. But on this plant here, it has looking a very, very promising, in my mind, really good root system. And look at the depth that this is coming down to. So we are getting reasonable penetration into this. Oh yeah, look, wow, this is so soft. Yeah, okay, right. Wow. Yeah, so different from over there. It was really quite hard over there. This is completely soft. So that's very encouraging. Look at these roots that are absolutely coming down much deeper and looking a lot more, I would say, a lot more robust, and a bit of soil sticking to those roots there as well. Very encouraging. So that's what we want to see. That's what this is, the process of soil formation that we talked about earlier, and equally we extend that into the ability of the soil to restore the plants, to restore some soil health, be that for the physical structure, the organic matter, the nutrients that then will cycle through that, and the biology, etc., etc. So I think that looks, here's a nice example there, looking very, very encouraging, and that's really what we want to see. And it just opens up that discussion about then the diversity effects, and whether or not when we get a couple of different roots here interacting, that actually there may be some of these 1 + 1 = 3 type interactions that encourage the plants to grow much deeper than they would normally by themselves, or again release very different root exudates than they would by themselves. And these variables are just infinite, and we really just don't know. And you know, I think it's great that we're all having this discussion about multi-species pastures and some of these interactions. You know, many farmers are saying, feeling, anecdotally observing that they're getting benefits to them. You know, I know, you know, rapid gains in soil organic matter. I know this is very disputed and debated by amongst many of the scientists who say this is just not possible, that you can't build carbon so quickly and in these kind of contexts. And I think it's great that we're having these conversations, and both the difficult ones and the good ones, because it's how we are going to advance this discussion, advance the practice and the movement. And you know, I don't know myself. You know, I know that what the science also says, and that we're doing things that may be unexplainable, but it doesn't mean that they're necessarily impossible. So I don't know. I keep an open mind, but I am encouraged to see things like this, and other times that I've been and looked in multi-species pastures and seen just fascinating things that you just don't normally see in monoculture production. And I think it does open that discussion for acknowledging that maybe there are things that we don't know, maybe there is more potential than what we think. But again, we have to be careful about overstating claims as well. I also agree that we need to be careful about that too. But nonetheless, that looks kind of very encouraging to me. And this is exactly, really what we want to see. More of this roots. That's your key driver of whatever you want to improve in your soil. And that's the thing, if it's soil carbon for payment, or if it's productivity for livestock grazing, either way, it's all one and the same thing. You know, if you're building carbon, if you're building soil organic matter, you're going to be building the productive capacity of the plants, of the system as well. So I think it's only win-wins all around. I know we're all very tunnel vision focused on soil carbon at the moment for payments and all of that kind of thing. And sure, I think it's great that that conversation is happening, and that farmers are potentially in a position to get rewarded. I think that's great that we're having this discussion. Of course, there are many unknowns still on how long you can sequester the carbon for, how stable it will be. If you get paid, we have to pay it back. Like, there's all of those kind of challenging questions at the practical level. But fine, like, let's work through those. I think that's okay. Let's just kind of work through those discussions. So I think it's encouraging that farmers are in this position. But it's not just about carbon payments. You should be wanting to do this because it actually improves the asset, which is your soil, your most important asset on your farm. If you don't have functional soils, you don't have a farm. So the motivation to build soil organic matter extends way beyond a carbon payment. It's important for the health and resilience of your farming system, and that impacts the landscape and the wider ecosystem, as we also talked about today as well.
An obvious question in my mind is, this is basically sand, the orangey stuff.
Yes.
Geologically, what's the difference between this and that one? Is it just more clay, or is it more complex?
Yeah, good question. Why does it set versus not set? I don't know.
There's more iron, probably more aluminium down there.
Okay.
Yeah, it's basically chemically cemented together.
Well, I mean, that's an obvious, in my mind anyway, is why those roots have gone deeper. It's because it's
Better structure.
and also if it is aluminium, then that would tend to burn them up.
If the pH is low, yes, the aluminium is released, and it'll be toxic to the root. But of course, the more aluminium you've got, the more potential you've got to be released. Like some of these really white glacial sands just have no clay in them, therefore no aluminium, so you can have a pH of 4, but you'll still have no aluminium. That's 4 in calcium chloride. But something...
4.5.
Yeah.
2019.
Yeah.
Really? 4.5? Yeah, Jim.
Yeah. But if it's got no clay or no other form of aluminium there, you won't get the toxicity. Whereas a little bit further down, if you've got a little bit of clay there, then that aluminium would definitely be released and it'll cause problems.
And I think the other point which is to talk about here is that yes, a sandy soil, it does have less of a capacity to also sequester carbon as compared to a clay soil, for the exact same reason that sands can hold on to moisture and nutrients. It's the same. They have lower number of their kind of charged surfaces for them to bind to and hold on to that moisture and nutrients, and the same is true of soil carbon. They have less negatively charged sites, less colloids to hold on and sequester. Now, that said, there's a bit of grey area in this discussion, which is that when we talk about soil organic matter, again, this is part of that emerging kind of different paradigm that I was alluding to about the root exudates. We also have kind of new ways in which we're kind of classifying and thinking about soil organic matter. Basically here touching on maybe the different qualities of soil organic carbon. It's not just about the total quantity, but also what form that carbon is, so the quality of that carbon. And we have kind of two new terms that are being used currently in the literature, and I'm sure they'll weave their way through more into mainstream lingo. And that's really just trying to separate out some of these different qualities of soil organic matter. And there's kind of two terms that are being used. One's called particulate organic matter, and one is called mineral associated organic matter. And as the name suggests, mineral associated organic matter is the fractions of soil organic matter that stick to those sands or the silts or the clay colloids that get stuck on there, and that interaction, that attraction, is a chemical process that helps to then stabilize that soil organic matter. So that's a very stable form of the soil organic matter, this mineral associated, stuck to those mineral surfaces. Now, indeed, it is that fraction that, yes, we talk about this concept of soil carbon saturation, that there's an upper limit to how much carbon soils can hold. It is that fraction of carbon, of soil organic matter, that, yes, does saturate, because it is dependent on those mineral surfaces to form. So once you saturate the clays, the sandy colloids, and it's full of carbon, well, you can't fit any more in. All of the charged sites are occupied, the car park is full, you can't fill any more in. And sure, versus a clay soil, it has much huge more number of negatively charged sites, colloids, it can therefore store so much more. So yes, clays can hold more than sand, and yes, they saturate at different levels, but that's referring to the fractions of carbon that attach to those minerals, the mineral associated organic matter. We also have another fraction then, which is called the particulate organic matter, and that fraction of organic matter in soils is not dependent on mineral surfaces, so it is actually a fraction that does not saturate. So it's this debate about saturation it is partially true that soils saturate, but that's really referring to the mineral associated fraction. The particulate organic matter fraction is really what I was talking about before, what I'm referring to. And I should stress, the mineral associated organic matter that I was just talking about, that's particularly prone to getting stuck to the mineral surfaces, that is especially that microbial necromass. So it's the root exudates and the biomass and the necromass, it's that pathway, the microbial contribution that we talked about earlier, that particularly then is prone to getting stuck to the mineral surfaces and forming this mineral associated organic matter. And however, we also have the particulate organic matter, and that's really what this stuff was. I talked about a continuum of decay. That's really what particulate organic matter is. It's all of more of the plant contribution, the plant fractions, that is in all sorts of states of decay, from large and complex all the way down through to the smallest of bits. And the point is that that fraction is basically doesn't saturate. You can just keep building and building and building and building that into the soils. Now, however, because it's not attached to the mineral surfaces, means that it is vulnerable. It is in that state of decay, but it's also being vulnerable to be kind of broken down and turned over and cycled in and out, like we were talking about earlier, and lost to CO2. So it's not generally considered not as a stable fraction of the soil organic matter, but in theory it can just keep sequestering. And this is what we basically see in forests, that leaf litter layer that just keeps on building and building, and then goes through that progressive state of continual decay, adding more decay at the bottom of that mulch layer. It's particularly, you'll find in forests is where we get these huge amounts of particulate organic matter, irrespective of whether it's a sand or a clay material. And so that's the essence. So I think that to say that saturation thing is a fair statement, I think it's broadly valid, but there is an opportunity to sequester more of this type of fraction if we just have more of this kind of residue and more cycling working in the system. And of course the other point is that, as we're alluding to here, well, what if we get deeper roots? Yes, maybe if the soil is saturated, but what if we grow more topsoil? So what if we get more roots going down, converting more of that fairly inert sand into more roots and decaying roots and all of the biological activity that comes with that actually we can sequester more carbon if we just grow more soil depth. And especially when you grow more soil at depth, because it's at depth, it's also more stable. It's the carbon that's up here on the surface that's always very volatile, very reactive, potentially easily lost. The more you can capture carbon deeper down through roots, or again through the root exudates in that microbial contribution at depth, because of the depth factor, it's also more stable. So there are opportunities here, I think, to build carbon, and despite all of that debate, I kind of think, who cares? It's very clear that our soils have lost a lot of carbon since European settlement. You know, our methods that we use, we did burn through carbon. Pretty much all of our soils have lost carbon. Let's just start putting it back. Let's start rebuilding it. And sure, we can have this debate and this discussion about what the top end of that is. We'll have that discussion on the way. Who really cares for now? I think we all need to be agreeing to take that steps forward to just, okay, do the practices that help to build soil carbon. And we'll have that debate about saturation at a later time. Who cares? We've got a lot of room to improve first before we have to worry about whether or not the soils are going to saturate or not.
Well, the solution's obvious. You just dig lots of very large holes and fill them with coal.
That's true too.
Could you repeat that, please?
Oh, he just said.
I heard the laugh, but I couldn't actually.
Oh, he just said there's an easy solution to dig lots of holes and fill it with coal.
Oh, yeah.
And of course, yeah, that's where maybe we've talked about this too as well. Things like maybe there could be some potential here for biochar. I think very relevant in a light sandy soil where we are, that point about mineral associated organic matter being dependent on mineral surfaces. If you were to apply biochar to a light sandy soil like this, that's what you're doing. You're applying a permanent surface that then more soil organic matter can bind to. So that's the benefit of the biochar. It's adding a surface that potentially more of those root exudates and microbial necromass can ultimately be stuck to. So that's what you're trying to achieve with the additions of biochar. So
having said that, I would add that if you put things biochar at depth, I would suggest that it be loaded with nutrients of some sort as it goes down, because otherwise you're prone to having problems, especially in these soils which are pretty infertile anyway.
Yes.
Hence the advantage of feeding them to ruminant stock.
Yeah, as long as you've got dung beetles or something that's going to actually get it deep into the soil. If it's just lying on the surface, it's not as beneficial.
No, but you think as the, well, say, sheep shit, it breaks down into very small particles, and won't they just get washed?
Well, no, it hasn't. It might over several hundred years, but you know, I'm a bit impatient. I'd like to see it happen a bit faster. And we've seen cases where people have been applying stuff to the surface for years and years. They've got a beautiful 10 to 15 centimetre thick layer full of roots, full of nutrition, and underneath it you've got nothing. It's like a dead zone. And it's like, you know what, if we can just fix that up a bit, all of a sudden your roots have doubled the volume of soil they've got to work with.
That's where the rivers go.
Yes, something that can do the job without causing a hell of a mess, hopefully.
Yeah, I would echo that sentiment about charging biochar with nutrients. This is also very, very important. It's key to successful use of biochar. It can actually rob nutrients from the soil in terms of the plant available fractions anyway, making it reductions in plant growth and production, biomass production, plant growth. So it definitely needs to be charged with nutrients for sure.
And that's where your septic tank comes in.
Yes, yeah, as a big sponge to mothball up all those nutrients. Yeah, it's true. And I would comment. I just noticed down here there are roots all the way to. I can see roots totally at the bottom of this, the depth of this pit. There is root activity all the way down here. You can see this one here, and I just pulled this one off here, which was, you can see that line down there. It was just sitting here. So I can see root activity completely. There's more there at the bottom of the level. There's some there. So we are getting roots down here. Again, very, very encouraging that the physical issues are not so limiting here. We are able to get some roots down. So I think there's very good potential for this area of the field, and it's fascinating that this is where you got the establishment of these covers. So I think you're definitely getting good roots down here, good opportunity. Okay, we need a lot more, but at least we can. I'm encouraged to see that at least there are some down there. So clearly the potential is there.
If you had kai growing here, how deep would you expect kai roots to go?
Same depth. Kai tends to stop about there.
Right, so it's shallow.
Yeah. Even in the swampy sort of sands where there's plenty of moisture, it's really that thick.
Okay. Yeah. So, don't get me wrong, I know as a grass it has other value, and as you've talked about at certain times with green ups and etc. At the right time and the right place it can be valuable, but I would say that the key here is we need deeper rooting species. So I would just try and get a bit more diversity of some others, and sure, Kakayu can be part of that, but I think you definitely need some deep roots here.
I guess that's good to point out to Derek that's which is exactly what he's trying to do with the soil care. That's what the attempt is. So that is the right path. It's just getting the practicalities of trying to get it to actually work.
Yeah.
The theory is great. It's just the enactment of it that's
working this little bit.
Yeah. And it's also, I think, great just to point out, very sandy soil, so low moisture holding capacity, but still was able to grow, some biomass here of these varieties. Heavier soil, even with our kind of, our dry summers, and it wasn't an especially wet summer, so, heavier soils should have more potential. So the questions earlier about what can be done in our systems in our summers, probably a lot more than what a lot of people expect is, I guess, my answer.
Yeah.
We've actually got an issue, like you have, with patches of bracken. How deep do the bracken roots go? So not, again, quite shallow.
Where we've got bracken fern.
Where we've got the bracken fern is fairly deep white sands. So it's white sand, usually with a layer of phosphorus underneath. There's one good photo of our bracken sands in that little photo booklet back in the shed if you want to have a look at it, towards the back. And that's anywhere, the white sand is sort of anywhere between a foot down to 3-4 feet deep, with a little bit more nutrient underneath it. But yeah.
I've been periodically mulching the bracken, like mulch, but also underground, but I've never dug down to find out.
It was actually interesting where we planted this mix in spring in areas that had bracken. They actually persisted a lot better because they were shaded through the hot summer until the top of the bracken, and so we had the little sunflowers that survived were twice as high in the bracken than they were out on their own. So that shading effect.
We're just periodically doing it because I don't want to eradicate it, even though it'd be against the law to eradicate it.
Yes, we wouldn't do that.
Yes, I've noticed the same thing. The kai hangs in longer and it grows higher. The main problem, of course, is you can't slash it. You've got to wait until it's fully developed.
Yeah, I think the bracken ground, because there's a lot of carbon in those roots, I think the potential to get something to grow in those areas is in some respects a bit better than in the heavy kikuyas without the bracken, because there's that shading effect. Now I know that planting trees, I've got a little bit of agroforestry going, and if you plant them in bracken, they get up to there before the kangaroos even notice they're there, and then they're gone. So it's, you know, there's that that ability to create a little microclimate, you know, of benefit. That's right. Yeah.